Hi everyone, in this video we are going to see our solved gate question paper of the 2024, and I am continuously solving the questions one by one in each of my videos. This is part 6 video having one question under the topic threats. It is an important topic and we can expect at least one question in this model every year. Let's move on to the question. Question is, which of the following statements about the threads is are true? So we have to find the true statements among the following options. Option A, threads can only be implemented in kernel space. B, each thread has its own file descriptor table for open files. C, all the threads belonging to a process share a common stack. Option D, threads belonging to a process are by default not protected from each other. Actually, the answer is option D. Let me explain by analyzing each of the statements. So, option A, threads can only be implemented in kernel space. This is a wrong statement. Why? Because threads can be implemented in different ways, particularly in user space threads and kernel threads. User space threads are managed without kernel intervention, and kernel threads are managed by the operating system kernel. So according to this, the statement threads can only be implemented in kernel space is a wrong statement. Option B. Each thread has its own file descriptor table for open files. So this looks pretty right, but the answer is wrong. This statement is false statement. Because threads within the same process access the files like shared file access. Okay. In this, they will share the same files and also they will have the same file descriptor table. This allows the threads to access the files that are opened by the other threads. So each thread has its own file descriptor table for open files is a wrong statement. They have a shared file descriptor table. Option C. All the threads belonging to a process share a common stack. This is also a false statement because the threads within a process can share the address space, but each thread will have their own stack so that they can use that stack to store their local variables, return addresses, and other call functions informations that are specific to that thread. So, any thread belonging to a process can share the address space but not the stack. They will have their own different identical stack. So, this statement is false. Next, option D. Threads belonging to a process are by default not protected from each other. This is a true statement because the threads that are under one process, okay, so they can potentially share the address space and they can access the same data within a same process. This means one thread can read, write, corrupt data used by the another thread unless they have a proper synchronization mechanism. Synchronization mechanisms like mutexes, semaphores. Mutexes ensure exclusive access to the shared data, thereby prevent the corruption, and semaphores controls the access to the shared resources so that they can allow limited concurrent accesses. Without these synchronization mechanisms, the risk of data corruption is there and due to the unregulated accesses. So, here the given statement is threads belonging to a process are by default, that is without any synchronization mechanism. They are not protected from each other is the correct statement. Answer is option D. Hope you understand this question. Please subscribe for more solved gate questions and thank you for watching this video.